It looks nice. One of the reasons is because though it's actually a bulky instrument, they have added a bevel here to make it little smoother as well as more convenient to handle. Similarly at the back also, except that if you see carefully, the chamfering which is shown here is little steep compared to this, and then various things have been added here, and then something in the front. This is regarding the various things, and then various aesthetic and ergonomic considerations. And then what they have done is they have also provided a small gap here, so that when it sits, the inside edges sit flush. And this has been, this is universal. I think earlier also I showed you about it. Front flat and then a beautiful design here. It looks a little high tech. And then you have something here, and then there's a corners. Somebody has made models out of it. And tried to find out that these look better. This is a earlier hard disk. Seen this? There is a beautiful curve here in the front, and the same thing is reflected at the back. So at that point of the time, then there is another gentle curve here. There is a gentle curve here, and the whole thing is something which is desirable and which is wanted, and so on. Something to prevent it from moving on the board. Now, thanks to CAD, we need not worry too much about how these dimensions, do they make sense or not. So what I will do now is, I will try to see if I can straighten this piece out. I have this and this. Ah, 22.36 did not change, but it got straightened out. Now I will pick this whole lot and see next piece got straightened out. I noticed that here now things are not so good. Straightened. Straightened out. Oh. It's nice. It is straight, and added to that we have total dimension of the blank, and where all we can do the various types of operations in this, and we have not compromised on any of the design dimensions we have started with. Now comes the important thing is that we go to the fabrication shop, find out how to include the bending allowance depending on the thickness of the material, depending on the flow of the material. do we add an elements or do we subtract an elements, and are we using coining, are we using air bending, or are we using folding where part of the thing and all that is there. But the starting point is very much possible for us. Randomly here I will give you bending elements of 1 mm. So easier for me now to just move these along. I have selected the points with which we play around. Watch the 64.12, 64.12. has become, hey, 65.12. I have added a 1 mm bending elements somewhere in these lines. This is where you need to carefully watch out what can happen. So another way of doing it instead is I leave the lines as it is and try to physically add a bending elements here by offsetting this point here. See, there is a small gap. I have added 1 mm here, and then from here I will do faster. Now if you see, though from a distance you cannot see it here, very conveniently, without having to worry too much about what has happened there, I have added the bending elements. Now the next point is, when I now try to dimension it again, depending on, of course, and depending on if we are trying to use a programmable machine, hey. You see, the 22.36 has become 23.36. So I will be a little faster from this point. Originally, our construction started with some idea of what we wanted based on the probably internal size. Now at the 4 points I have added a 1 mm bending allowance. You see that overall my blank length has gone up very nicely without my having to worry too much about it. Now comes the important as to why I did all this, and then I try to delete all this and then come back to old views as we have seen before. Pardon me for going back and forth. We come to this important question of what happened now? What happens to all the bending allowances and all we have added? Now here we need to go back to the old that exercise what I have shown you. You should have the dimensions and the part that is required after all the operations have been made, or the part drawing issue. So if you go back to our construction line, you see that was only an imaginary line. It was just an imaginary line for which it needs to be done. But now we have to take the important decision of whether you want it as an internal or you want it as an external dimension, or would you like it to have half of it here and half of it there. How do you go about building all these things? So I will try to quickly go off into see here what can be done. Remember, this is a simple profile. Maybe my trying to make it thick, does it help? Yes and no. Only one thing here you notice is there is a serious issue about the what do you call radius has not been mentioned here. Two radiuses are very, very critical. One is the machine and or the bending tool has a inside radius, like we have something like this, no, this is where the coining takes place. So the radius of this, no, this is very, very critical, that forms the inside radius, and afterwards we have the sheet thickness itself, outside radius comes here. But however, if you see my drawing, no, very conveniently it ignores everything. It shows, perfect like this, and maybe something is done. This is where proper advanced sheet metal packages take care of the internal bending radius as well as the external bending radius. Just to sort of show you how to make the filleting, I will give a radius of 0.5 mm for the inside bends. See here, from here to here is a 0.5 mm. Internal only is, remember. You see, internal has become 0.5. This has to be continued in all the places where the internal has to be done here. Can you see here? I have a beautiful internal radius also. Now in this case, so that the visibility is high and so on, and the same thing I can use for using for plastics, I have used a large thickness of 3 millimeters. Typically it's a 1/8 inch acrylic or PVC or polystyrene or polycarbonate sheet. So we have this beautiful thing here. Now I will try to quickly 0.5 as internal, I will add 3 mm and then make the filleting. The radius is now outside is going to be 3.5. You have seen here slowly things are see, this looks more like a natural piece. In the case of plastic, you can completely avoid all this filleting inside, because you can take any of the two pieces, cut and just stick them together. You need to emery or sand the surfaces and stick them together. So I can go back and create this directly in acrylic, colored acrylic is there, and then depending on how serious or how important is the surfaces and so on, you can always decide the overlap. Oh, let me put it here, saying what does this overlap, or does this overlap here? I think I will start here. Does this overlap here or overlap here? Or would you like to make it into a perfect, joined together peacefully in a corner like this? So this is valid both for sheet metal as well as thermoforming. We have things which I am sure you would have seen the blister packs, for which most of the things come by. All blister packs are essentially thermoformed. You have a former, typically the former has this shape, and then they keep the sheet on top of it, they heat it, and then a vacuum is applied and takes the natural form of all these things. So thermoforming is just talking about the heat part of it, the other vacuum forming is applying a vacuum on the base. So such things can easily be made by thermoforming. Having done this, now comes to the other point of how to lay it out, and then how is it going to look anyway. So allow me to go a little faster again. I have now something which looks quite how to say, interesting. I have made all this whole thing into a single sheet. Now I will try to make a solid out of it by extrusion. Oh, it seems to work. Now if I give a rendered image, you see here, I have a very nice, beautiful object. It could have been sheet metal or it can be thermoformed. Now we need to worry about what do we do with the bottom piece of it. You notice here, we started with a line here, that line is probably still sitting here somewhere. You have seen that. Now can we use the features of this line, like this internal surface, no, which should go and meet the internal surface and then try to make something which is in the other direction. This is where all our skill and various things come about. Top portion was relatively easy. Now how do we make the bottom portion? Good proper packages, they work in a very intuitive and nice way. In this case, I will be forced to do a little bit of an exercise, saying now how do we create something which has at this edge, however it has a thickness like this, that it is not easy, but it can be done. Not easy, but as I said, no, it is very easily it can be done. So what I need to do is make a U and then try to see whether I can cut it and so on. Right now what I will do is I will hide this or delete it. Even better is delete that thing. See that now I will see what best I can play around and see whether something can be done with it. I have started with a simple line to see if it helps me what I can do with this line here. Here slowly, we are getting into a little bit of what are called Boolean operations and how to make things match and so on. I showed you this when we started with the sheet metal exercise, what will happen into the corners and so on. There I had done it, but not on the fly here, meaning somebody has actually helped me. Now I need to figure out what to do with this line. I have a beautiful line here. Now do I offset it like before and take it here and see whether I can trim it such that the bottom fits nicely. I will see how best I can manage it. See there, I have created something else in the other direction. Once again, we end up with having to extrude it and see how well it fits or doesn't fit. Let me try my luck. So, I have this beautiful device here, and once again I will try to see if I can fillet the curve as I have shown you earlier. I fillet this point. Now again I fillet the outside curves. Sorry. Well, so far so good. I have a beautiful a device to carry out the extrusion. Now I look at it in this, I'm sorry, I need to join the whole lot. First explode it, join it, make it into a single curve, and then see how well I can carry out the extrusion. Now as before, try to see if I can do something about it, and specifically not bad. I am somewhere at least, except that you see it seems to be not very well done. It seems to be hitting each other and not so great and all that. Is there something I can do about it to improve it? That is where, as I said, all the Boolean operations things will come. So I do it in a very crude way just to make sure that it works well. So I have 3 instances of this sitting here. So the 3 of them I have here. just to check whether I can do something with it. You have seen something is sitting here, something is sitting here. I will see what best I can do with it, whether I can trim it, whether I can I am not very clear what I can do with it. It looks like it is very much possible for me to trim this into several surfaces, and then now I will try to attempt to use this top surface, return, oh, it does not seem to work. Now let me try. Actually, surfaces can be trimmed by exploding with the other surfaces. I will see whether I can try to do a what you call difference between this see what has happened. I do seem to have ended up with something which is what I was looking for. Can you see it has that beautiful appearance which I was looking for all along. Only thing is I need to do something and get rid of it. You see, this is what I was looking for. If only I had paid a little proper attention and got this sitting properly, probably I would have I will keep it back where it was and now put this there and see whether what I can do with this there. Again I try to do the difference. See, I have got it. In this I have a curve is generally all right, except that at this point it did not get cut fully. My problem was that at this point if I had lowered it a little, probably I would have achieved what I wanted. So I will now go back, I will go to the undo point of it, I will again go back to the undo, go back again to the undo. See here, now if I see the corner here, that it looks like is where actually the problem has started. Seen that? So, if I follow the original construction lines and then follow all the manufacturing issues which I was talking about, all it requires is probably I need to lower it a little. You see here, now it seems to cut properly, except a very small thing here which now if you see here, chances are this will work without any problem. All I need to do is take this piece, remove this material in it, and it works. It nicely sits in place. So, I will stop here and then try to continue next time with go back a little and then try to remove all the offending things, make a proper what do you call layout, and then try to work with it. I will continue with it. So, thank you. Let us meet again.